Hello, psychology class. This message is particularly for my odd day classes who I'm unable to Zoom with this week due to the shortened week and the fact that we don't have school on Tuesday or Thursday, which are your synchronous and asynchronous days. That does not mean that you're not responsible for this week's assignments. You absolutely are. And so all assignments this week still need to be completed. And I am going to go ahead and record my video lesson for you as if we were Zooming. And so you shouldn't feel like you have missed out on anything this week. So if we were meeting together on Zoom, this is what the agenda would be, and this is what I'm going to cover with you on this week's video lesson. So we're going to do a brain games video just to kind of get you thinking about the brain, which is our unit that we're starting now, and then I'll cover kind of a little brain lecture, and then at the end there's a short video on Phineas Gage, which is a case study about a man who actually had a railroad rod that got blown through his skull and damaged part of his brain, yet he survived. And so it's a little video like, how is that possible? How can you have something go through your brain and yet you still survive? So hopefully by the end of this lesson you'll be able to answer that question. As far as this week's assignments go, there's just one. It is an assessment format on Schoology, and it is understanding brain functions. I'll explain that in a little bit more detail in a few minutes, but this is your formative assignment number 11 of 12. All right, and so we have 12 formative assignments this marking period, and so this is your 11th formative assignment. If you're looking ahead to next week is the last week of marking period 1, and so as a result we will have 2 assignments. We will have our last formative assignment, which will be a study guide on sections 2 and 3, which will be formative assignment number 12. And then we will also have a summative unit test on sections 2 and 3, which covers psychological theories and then the brain, which we're going to discuss today. And this will be summative number 3 for marking period 1. That being said, if you have any missing assignments, then please go and correct them and get them submitted. How do you know if you have a missing assignment? You need to go into Schoology and click on the Grades tab on the left-hand side in Psychology and look and see what your grades are. Some of you have zeros, you need to submit work. Some of you have submitted work, but you submitted it blank or you submitted the wrong assignment, and there is a note next to it, and it says what I need for you to do in order for me to grade that work. So please go into the grade book, look at your grades, make sure they look right, and if there are any notes from me, please make sure you read them and that you collect them. I can't individually get to every single one of you for individual phone calls or emails. I have sent messages through Schoology. I know a lot of you are bogged down with messages. It is highly recommended that you check your messages daily so that you don't miss something important from me or any of your teachers. But again, checking that grades tab, you will see notes from me on the grade section. If you are missing something or if something was submitted but is not graded, you'll know why. All right, so please make those corrections this week. All right, so as we get into it, we're going to watch this short little video on your brain and see if you can do this.
Did you get a streusel top blueberry muffin today? Or is it a special day because you got a streusel top blueberry muffin? Meet the new bakery sweets at McDonald's. Ba-da-ba-ba-ba.
Pay attention. We're going to play a little game to test your mind-body coordination. What I want you to do is I want you to take your right hand and place it on your nose like this. And then take your left hand and loop it under your right hand to hold your right earlobe. You got it? Okay. Now when I say switch, I want you to reverse it. I want you to take your right hand to hold your left earlobe and your left hand to hold your nose. You ready? Switch. So how did you do? Did you get it? Or did you maybe mess up? Don't feel bad if you messed up. Sometimes your body has a mind of its own. But with a little bit of practice, you can get your brain and your body working better together. Let's try another one. Okay, here's one you can try right from your own couch. Using your lap as a surface, I want you to take your left hand and I want you to place it on your left leg. Now make a fist with your right hand and place it on your right leg. What I want you to do now is I want you to gently move your left hand back and forth in a sliding motion as though you're standing a surface. And then gently lift and lower your right hand as though you're hammering. You got the motions going? Okay, good. Now when I say switch, I want you to reverse it. Are you ready? Switch. It's not as easy as it looks. Did your left hand try to make a sliding motion with your fist? Okay, we're going to really pay close attention and we're going to try to do it together now. And let's see how many we can get correct. Are you ready? Okay. Switch. 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 So how many did you get? Did you get one correct? Maybe two? Did you get all of them correct? And are you curious why these coordination games are so difficult? The coordination of both sides of your body happen in a single place in the brain, the cerebellum. And when your hands have to switch while doing simultaneous tasks, it causes something called bimanual interference, making your brain pause over the action that it's trying to do. And now that you know how these games work, you can try them at home with your friends. And with a little bit of practice, you can get better at them. But as you know, the first time you do them, they can cause some serious brain-body mix-ups.
Okay. So hopefully that was fun and got you thinking. How many of you, I wonder, were able to do it? I will tell you from my personal experience, the first time I did this, I messed up. I couldn't even do it. I was like, how is she doing that? And then, you know, I've done this several times. Once when I was planning the lesson, yesterday I taught Zoom and I did it 2 times, and then I just did it again. So that'd be my 4th time now doing this while I was recording this video, and I got them all right this time. So it just goes to show you that practice makes perfect, and that we can actually teach our brain to become better and to become more coordinated if we just practice. And so if you've ever heard that before, practice makes perfect, it is in fact true. And this goes for not just sports, but, you know, playing a musical instrument or drawing or something creative, anything that you want to get better at. The more that you do it, the more repetition, the more coordinated your brain will get, and the much easier and smoother your transitions will be. All right. So as we get into this last section of marking period 1, we're on section 3, which is the brain. I'd like to point out that this is not in your textbook. All the information for this section is in the chapter 9 folder. So everything you need this week will be there, and you will not be able to find anything in the book. This is just a fun little picture that's the anatomy of a teenager's brain. And so it's funny because, you know, it points out that, you know, this part of the brain controls the birds and the bees. This is for memory, for music function. There's a little teeny gland there for a judgment gland in teenager's brain. Even smaller gland for the memory to do chores and homework. And then, you know, there's like a yin-yang here that shows, you know, love for parents, but at the same time a disdain for parents. And so it's funny, right? Because it's making light of a teenager's thoughts. However, what I want to point out is that this divides the brain into different sections, and these different sections are controlling different things. And so what we're going to get into today is we are going to look at the lobes of the brain and what each one of them actually is responsible for and controlling. So before we get into it, what I'd like you to do is to make a fist with both of your hands and hold them palm to palm so that they look like this, okay? This is roughly about the size of your brain, okay? And I really wish we were in school, because if we were, I have so many brain models that I could show you. What you may or may not know about me is before I was a teacher, I was a certified athletic trainer. And before I started teaching psychology, I actually used to teach in athletic healthcare and physical therapy, and I still currently teach 2 classes for Del Tech. I teach Del Tech Nutrition and Del Tech Medical Terminology. So the brain is something that is near and dear to my heart, and that I know and understand very well. And I have lots of models in the room that would have really helped us to be able to learn this a little bit better. So I've really tried to add some videos to this to help your understanding. I also have really tried to add some images and some graphics that I think will help you in understanding this. But again, typically your brain is about the size of your 2 fists kind of put together, and it is divided into 2 hemispheres, all right? And so we have a right hemisphere and we have a left hemisphere. And then also, if you look at the brain, it does have some raises on it, which I like to call, it looks kind of wrinkly. And so the knuckles here, kind of represent some of those raised areas of the brain, which we call gyri. And then the deep grooves in between my fingers here represent the grooves on the brain, which we call sulci. All right, and so if you look at this picture here in the upper right hand corner, you'll see the brain does look kind of wrinkly, and so it has these raised portions, and then the black lines represent those deep grooves as well. All right, so it's not smooth and flat in appearance. So question for you, out of all the activities that you do in a day, which ones are not related to the operations in the brain? So pause for a second and think. All right, as you're thinking about different activities of the day, hopefully you came up with the answer of the fact that this is a trick question. All the activities are connected to the brain. If you think about when you woke up this morning, even the act of waking up and your body being alerted to wake up, your brain helped to control your sleep cycle and know that it is morning, it is time to get up. Physically getting out of bed is a movement. Your brain helps to control that movement. Going and brushing your teeth, all right, combing your hair, getting dressed, all these movements are controlled by your brain. And lastly, were you hungry when you woke up this morning? That feeling of hunger or a feeling of thirst, those are also controlled by your brain. And so we are going to learn which areas of your brain control each one of those different functions that I mentioned today. All right, here's a video by the National Geographic. This is a Brain 101 video, and it's just informational and helps you kind of visually see the brain and the different parts of it and what they control. I'm not going to watch this video with you on this PowerPoint lesson right now, simply because I'm going to go through and teach the brain for you. But if you need to go back, or you're interested in going back and learning more about the brain, this is not a very long video. It's just a few minutes, and it'll help you review your understanding of the brain. So you can come back to this. Okay, so before we get into our study of the brain, I want to talk to you quickly about the assignment this week. So there is a document in the Week 9 folder called Key Structures of the Brain, and this document contains a chart, and on the chart are each of the following: a part of the brain structure, a function of the brain, and then a region located in the brain. All right, and so your job is to use this document to complete the assessment, the multiple choice assessment in Schoology, to identify each area of the brain's function. So I'll give you a clue, and I'll say this area of the brain is responsible for, interpreting what our eyes visually see, and it is located in the occipital lobe. And so you're going to look at the chart, and you're going to say, oh, that must be the primary visual cortex. and you'll go ahead and select that as your answer. So you'll need to have this document in front of you while you're completing this week's assessment. And if you'd like to see what that document looks like, I will show you. Okay, so here are here is the document, again with the 3 columns, and you can see they're divided into the structure, the function of that structure, and then location within the brain. All right, and so I'm getting ready to teach you all of this on the PowerPoint slide, but this document in particular is just kind of your notes for the week. I'm not asking you to fill anything in. I'm giving you everything that you need, so you need to have this document in front of you as you're completing this week's assignment. As you'll see, there are 10 structures of the brain that we're going to be going over, and we're going to be going over them right now. So let's get back to it. Okay, the first area of the brain that we're going to talk about is called Wernicke's area. And this area of the brain is responsible for understanding language. All right, and it is located in a part of the brain between the temporal and parietal lobes, specifically on the left side. And so I want to draw your attention here to this image on the left. So this image on the left has different colors on it, and each color represents a different lobe of the brain. All right, and so you have the frontal lobe, which is also located right here behind your forehead. We have 2 parietal lobes, one on the right side and one on the left side, which are kind of on the top of our head right here. We have 2 temporal lobes, which are located right here. If you know where your temples are, all right, you can find them. So if you put your 2 fingers on your temples, just underneath that bone there in your skull is the temporal lobe. And then in the back of your head, it's represented in yellow on your screen. This is the occipital lobe. All right, so these are the different lobes of the brain, and we're going to talk a little bit more about them. We're going to talk about specifically Wernicke's area, which is a small portion located in between this parietal lobe and temporal lobe on the left side. So here's the left side, here's my parietal lobe, here's my temporal lobe. So we're talking somewhere in between there. Oh, yep, right in there. This is going to be called Wernicke's area. And again, it's responsible for understanding language and is represented by the orange dot right here. All right, we're going to watch this short 2-minute video to help you understand this area a little bit better. And in this video, they're also going to mention Broca's area, which is represented in blue right here, which we'll talk about on the next slide.
I have to stop and tell you guys about Lecturio, Lecturi.
Welcome to 2-Minute Neuroscience, where I explain neuroscience topics in 2 minutes or less. In this installment, I will discuss Wernicke's area. Although there is some debate over the exact location of Wernicke's area, it is typically considered to reside in the cortex of the left cerebral hemisphere, near the junction between the temporal and parietal lobes. Wernicke's area was named for the German physician Karl Wernicke, who reported that damage to this region results in a deficit, where patients are able to produce speech that resembles fluent language, but actually is meaningless. The disorder came to be known as Wernicke's aphasia, and patients who suffer from it do things like use made-up words or similar-sounding words substituted for one another to produce speech that makes little sense. Patients with Wernicke's aphasia also suffer from a deficiency in their ability to understand language. Wernicke proposed a model for language that involved both the region he discovered and another language center, Broca's area. Broca's area is thought to play a role in speech production, and Wernicke's model, which was later expanded on by neurologist Norman Geschwind and called the Wernicke-Geschwind model, suggested that Wernicke's area creates plans for meaningful speech, while Broca's area is responsible for taking those plans and determining the movements, like of the tongue and mouth, required to turn those plans into vocalizations. It's now thought, however, that this model is too simplistic. Studies indicate that language likely involves widespread networks and cannot be boiled down to a connection between 2 brain regions. Additionally, evidence now suggests that Wernicke's area may be involved in speech production rather than just comprehension, and some have claimed it may not be as important to language comprehension as once thought. Thus, researchers are still trying to figure out the precise contribution of Wernicke's area to language.
Okay. So what we're saying here with Varnicas Area, again, is it's responsible for understanding language and putting together words. And so basically, if somebody had damage to this area of the brain, they may have trouble understanding and comprehending words. So if you were to have a conversation with someone that had trouble with this area of the brain, they may not understand the words that are coming out of your mouth. They may also have trouble trying to form the words, and it may come out something like gibberish. And so this could happen in the case of potentially a stroke, and this area of the brain being damaged, where someone maybe has trouble trying to figure out if you hold up a ball in front of them, let's say a 40-year-old individual, they clearly know what a ball is. They've learned it and played with it their whole life, but for some reason they're having trouble identifying the words that would be used to describe what a ball is. And so that would be very frustrating to have damage to this area of your brain and affecting your understanding of language. Broca's area, as they mentioned in the video, is very closely related to Wernicke's area. It's located more in the frontal lobe, so more in this orange section here on the left side. So, sorry, left side here, frontal lobe, so somewhere kind of up in here. And this is the center for expressing language. So again, so if Wernicke's area is determining what words you want to say, Broca's area actually makes speech possible. It sends messages and signals to your mouth and to your tongue to create the movements to make speech possible. So again, it's possible to have damage to Broca's area, and if Wernicke's area is intact, they may know what they want to say, but be very frustrated that no words will actually come out. And so there are some conditions where people have what we call aphasia, which is the inability to speak. These people are not unintelligent. As a matter of fact, they are very smart. Their brain works just fine, and they know what they want to say. They just lack the ability to actually make speech possible, and it could potentially be to damage in Broca's area of the brain. All right, moving on to the auditory cortex. Auditory means sound or hearing, and so this area of the brain is our center for hearing. It is located in our temporal lobe. We remembered where that is, right here. Okay. And while Wernicke's area and Broca's area was specifically on the left side of the brain, the auditory cortex, we actually have two of them, one on the right and one on the left, and this is because we have two ears responsible for bringing sound in that our brain has to interpret to make understanding of that sound of what we're hearing. And so on this picture here, what you are seeing is there is Wernicke's area we mentioned before and Broca's area. And right here in the middle of it, there is your auditory cortex represented in yellow. It's always helped me to remember that the auditory cortex was in the temporal lobe because it makes sense to me that here are our ears and the lobes that are closest to that are the temporal lobes. And so the proximity of sound coming into your ears and having to travel to your brain for interpretation of that sound, the temporal lobe is the closest. And so I've always been able to remember that just because of close proximity. Okay, our primary visual cortex. It does exactly like what it sounds like. Visual is seeing and images, and so its main function and job is to reconstruct visual images that come in through the eyes. And so if you look here, here are images coming in through our eyes, and you'll notice that our eyes are not just free-floating organs and structures. They have nerve endings that are coming off of the back. And so the nerve endings coming off of the right eye go and travel into the brain. It's called the optic nerve, and it connects to the back part of the brain here, which is located in the occipital lobe, and specifically to a special area in the occipital lobe called this primary visual cortex. All right, the left eye is the same thing. Images coming in, it crosses over through the optic nerve and attaches back here on the right side of the brain. All right, and so we're talking about, this is the occipital lobe here, represented in green on the image, and the very, very back or posterior part is called the primary visual cortex. And so what this means is, as things come in through your eyes, they again have to be traveled to your brain for your brain to interpret what you are in fact seeing. And so to drive this point home, if you were to, let's say, hit the back of your head and do damage to that primary visual cortex, it is possible that your vision could be messed up. This happens sometimes in the case of a concussion. If you've ever had a concussion or seen someone with one, if someone hits the back of their head, one of the things we might ask them is, do you have blurry vision? Do you have double vision? Do you feel like there's a black curtain coming across your field of view? These all indicate that there could be damage to that back part of the brain, which is causing these people to see double or to see blurry or potentially to see stars. Okay, so the eyes are fully intact. The eyes are functioning just fine, but it is the brain that was damaged that interprets those images that are coming in through the eyes. And so oftentimes with a concussion, these symptoms are temporary. The brain just kind of gets stunned or gets bruised a little, and as the brain heals, then vision usually returns back to normal. There are some extreme cases, though, where if there was permanent damage to this area of the brain, these people might have permanent damage to their vision, and in some cases, it could lead to blindness. Again, the eyes are functioning fine. It is the brain that interprets those images that has the problem. Okay, so moving on now, we're going to move more towards the inside of the brain, and we're going to talk about a structure called the thalamus. So as we made our two fists here, and we talked about that the brain has two hemispheres, what we're going to do is we're going to open up the brain, and we're going to look at the inside of the brain here, okay, more towards the very center of the brain, and this is where the thalamus is located. It is located in a structure that we call the forebrain, okay? And so you see that the forebrain is represented in orange here, and it includes the outermost portion, all right, which are those grooves and raised areas that we talked about before, which we call the cerebral cortex. But the forebrain also includes a little bit of the inside of the brain kind of in here, which is where we're going to find our thalamus, okay? So our thalamus is responsible for sending sensory and motor images, or sorry, sensory and motor messages to other parts of the brain. So we have to understand what sensory and what motor mean. Sensory refers to your senses. So we're talking about your sight, your taste, your touch, your smell. And so I'm going to specifically talk about the sense of touch, okay? So that's sensory, and then motor means movement, all right? Motor, movement, and you can remember this because the motor in a car makes it go. Motor in a boat makes it go. The motor in a motorcycle makes it move. All right, so motor means movement, and sensory refers to our senses. And so the thalamus is a relay center for messages coming into the brain and messages leaving the brain. And so as sensory messages come in, let's say through our skin, through touch, for example, if you were to touch something hot, like a hot stove, that sensory message would travel in through your fingers, and it would travel up to your brain, all right, all the way up into the thalamus here. The thalamus would then say, uh-oh, we need to do something, and it then sends this message to another area of the brain that's going to be responsible for movement or interpreting that hot sensation. All right, and so in this case, the thalamus sends the signal up to the cerebral cortex out here. The cerebral cortex says, that's hot, we need to move our hands so that it doesn't get burned. Excuse me. And so we quickly move our hand, that is the motor movement. The cerebral cortex sends a signal that we need movement to the thalamus. The thalamus sends that signal down the spinal cord to your arm, and we move our hand away so that we don't burn it. You can appreciate that all of this happens instantaneously. You know, if you touch something hot, you instantaneously pull your hand away. You don't have to wait for your brain to think, is that hot? And then pull it away. All of this happens instantaneously in split seconds, and it's the thalamus's job to relay that information coming in to an area of the brain, so that area of the brain, like the cerebral cortex, can then make a decision what to do, send a message to the thalamus on what the directions are, and the thalamus relays that on to the rest of the body. Okay? All right, so moving on to our cerebellum here. The cerebellum often is called the little brain because if you look at it, it's represented in purple here, and it kind of looks just like a smaller version of the entire brain itself. As far as its location, it is located in what we call the hindbrain, okay, which is represented in yellow, all right, on our slide here. All right. Hind meaning below or behind, okay? And so this is located on the more the underneath back part of the brain, all right, is the cerebellum. She talked about this in the Brain Games video, so if you played along and were trying to, slide your hand at the same time you were pounding your fist, and she talked about the coordinated movement of that, and she said this is controlled in the cerebellum, all right, which is back here. All right, so again, if you were to continue to practice that, the cerebellum would get better at this coordinated movement and you would actually improve. The cerebellum also controls things like your ability to walk, and it also controls your balance and equilibrium. So if you've ever been sitting, or if you've spun yourself around and you've gotten kind of dizzy and you're like, whoa, give me a second, it takes me a second to get my balance, the cerebellum helps to control some of that. And helps keep your equilibrium and your balance. And it might take a few seconds for it to catch up, but it will. All right, the cerebral cortex. We've talked about this already. This is when we made our fists, those raised areas, what I called the wrinkly part. This is also the outermost portion of the brain. All right, and this is where we have those lobes of the brain. Everything we've seen represented in these different colors of the frontal lobe, parietal lobe, occipital, and temporal lobes. All right, again, it's technically considered the forebrain, but it is the outer covering of the brain. All right, and so much happens in the cerebral cortex. We've talked about these individual lobes and what they do, but on the whole, the cerebral cortex, that outer portion of your brain, this is the decision-making center of your brain. It processes your information. This is what does your rational thought. It also controls your memories. And so it's a very, very vital, important part of your brain. Those of you that had the cognitive theory last week, and we said the cognitive theory is or cognitive psychology, and the approach to it is understanding how we do our thinking, processing, and storing of information. We're predominantly talking about studying this cerebral cortex, this outer wrinkly portion of the brain with all of the lobes. Okay. Okay, so moving on, we just have 3 more areas of the brain left to discuss. And so we're going to talk about this area called the medulla. You may have heard it referred to as the medulla oblongata. If you've ever watched the movie Waterboy, that's where a lot of people have heard the term medulla oblongata before. It is also located in the hindbrain. If you remember, the hindbrain was the cerebellum, and it's also this lower portion of the brain which contains the brain stem, which you see in blue here. All right, if we get a closer look at the brain stem, which is right here on the left picture, you'll notice it is made up of 3 parts. You have the midbrain, the pons, and then the medulla or the medulla oblongata. Just below the brain stem is the spinal cord. So the medulla connects the brain to the spinal cord, but it also has a very, very important function. Its main job here is to regulate vital functions such as breathing and blood flow. Vital means essential to life. These are your, like, if somebody was to take your vitals, they would be taking your heart rate, your breathing, and your temperature. All right, these are your vital signs, and these are things that let us know that you are living and breathing. Okay, and so if you damage the medulla, it very oftentimes is fatal, okay? Because this relays messages to your lungs to tell them to breathe. It also relays messages to your heart to tell it to beat. And so if you damage the medulla, then you sever those nerves that go to your vital organs like your lungs and your heart. If your lungs stop breathing or your heart stops beating, then this is essentially fatal, and which is why damage to this area is very significant, okay? How would you damage this area? Well, this is why you're told not to do flips on a trampoline, or to be careful and to make sure that you're wearing a helmet when you participate in certain sports or when you're riding your bike or a motorcycle. Because if you break your neck, all right, you could very well damage the medulla, which could be instantaneously result in death, okay? And so that's because the medulla, again, connects to the brainstem here. It is the lowest portion of the brain, and it is protected only somewhat by your skull and only protected the rest of the way by your vertebrae. So it is protected, but you still have to be careful with it. All right, the pituitary gland. This controls the body's endocrine system. So if you're unfamiliar with the endocrine system controls all the hormones in our body. All right, and so we have several glands in our body that secrete their own various hormones. So we have the thyroid gland in the throat, we have the thymus gland in our chest, we have the pancreas, and then we also have our reproductive organs. So in the females, we have the ovaries that produce hormones, and in males, we have the testes, which produce hormones as well. Why are we talking about those when we're looking at the pituitary gland? Well, the pituitary gland is often called the master gland. It is located in the brain. It's very, very small. You'll see it right here down at the bottom. It is below the thalamus and the hypothalamus, okay? And again, called the master gland because it secretes its own hormones, but its hormones go to those other glands and tell them how much or how little of their own hormones to secrete. So for example, the pituitary gland secretes a hormone that acts on the thyroid gland, and it tells the thyroid gland, hey, we don't have enough of your thyroid hormone, so start pumping out some more. Or it'll send a message to the thyroid gland that says, we've got enough thyroid hormone circulating in the blood and the body right now, shut it off, turn your thyroid hormone off for right now. So the pituitary gland regulates the amount of hormones that are secreted by the other glands in the body. So it is very essential, and again, located in the brain, and so our brain helps to control a lot of the hormones that are in our body. All right, and again, we said it is located beneath the hypothalamus. So let's talk about the hypothalamus. This is our last area of the brain that we're going to talk about. Hypo right here means below, okay? And so hypothalamus literally means below the thalamus, and you can see that represented here. There's the thalamus we talked about, and the hypothalamus is just below it, okay? Remember we talked about what activities do you do in the day that are controlled by your brain, and we said it was all of them. And I mentioned things like being hungry or being thirsty. I also mentioned your sleep-wake cycle and knowing when to wake up, and also just generally getting tired around the same time every day. The hypothalamus regulates all of those functions in the body. It regulates your hunger, it regulates your thirst, it regulates your sleep-wake cycle, and it also helps to regulate some of your hormones as well, or not your hormones, your emotions as well. So are you typically happy? Are you sad today? Are you tired? All of these different kind of emotions and feelings that you have are regulated here at the very center of your brain in the hypothalamus, again located below the thalamus and above the pituitary gland. All right, so hopefully this was helpful and informative to you. You could have just read the chart to complete the assignment, but I wanted you to really understand and learn these areas of the brain, again, because I just love the brain so much, and hopefully I helped you in understanding the brain and how it relates to psychology as well. So what you're now going to do is you're going to use the information that you just gathered along with the chart that is in the week 9 folder that I showed you earlier, and you're going to use that information to complete the assessment in Schoology. That again is requiring you to identify the correct part of the brain with its location and function. So feel free to revert back to this PowerPoint or video. Also use the chart that I gave you. You have lots of resources to help you complete the assignment this week, which is just a 10-point formative assignment on Schoology. All right, this is the last thing we're going to do today, and if you need to stop and work on your assignment and come back to this video, then feel free. But this is the video, which is a case study on Phineas Gage, and it's how psychologists can learn from tragedies that occur when people suffer from accidents. And so let's watch this short video together and see what happened to Phineas Gage.
Phineas Gage was once an ordinary railroad foreman. He was a happy, healthy, and friendly person until a freak accident caused him irreparable brain damage. Now, Gage is remembered as a famous medical mystery. The accident that drastically changed his life and personality also changed contemporary understandings of the human brain. The horrific accident occurred in 1848 when Phineas Gage was clearing rocks from a new railroad's future path. He was placing gunpowder into the cracks in rocks and then detonating them to clear them. One day, he made a mistake with his explosives. Gage forgot to cover the gunpowder he was patting down with sand. When he tried to pat the gunpowder into the rock, it exploded and launched a 3-foot-long metal pole through his skull. The projectile dragged parts of both his frontal lobes along with it. Despite the gruesome injury, Gage was relatively unaffected by the accident. Some reports say that he convulsed for the first minute after the impact, but many believe that he never actually lost consciousness. Regardless, he was undoubtedly conscious about 1 minute after the impact. Gage sat up and actually spoke to his fellow railroad workers. When they wheeled him to a doctor, he insisted on being given his time book to continue doing his job as a foreman. While Gage's determination to continue working despite his terrible injury may seem odd, the effects of his injury were even stranger. The open brain wound healed after only 10 weeks, and Gage was able to count, sing, feed and dress himself, and make sense of information that was given to him. Some aspects of Gage never fully recovered, however. His personality was completely different. His old friends could not tolerate his newly inconsiderate attitude, inexplicable temper, and constant profanity. Soon, he was fired from his job for being nasty to co-workers, people who he had worked well with just 10 weeks before. Gage was so out of control that men kept him away from women and children because he was considered too vulgar for them. Even though he had physically healed, something was still wrong. As his doctor said, Gage was no longer Gage. 11.5 years after the accident, Gage died. Unfortunately for the medical community, no autopsy was conducted on his unique brain. Years later, his body was exhumed with permission from his family, and scientists studied his skull. They saw approximately where the rod traveled through his head, and did their best to understand the damage with their limited understanding of the brain. The case study became an essential part of the debate regarding the function of the brain in the mid-1800s. Two prominent schools of thought existed. Ironically, both used Gage as support for their theory. One group believed that the brain was connected by a vital force. Due to this vital force, any part of the brain could perform any of its functions. Therefore, someone like Gage could still think and behave like everyone else, despite having lost a large piece of his brain. The other group of brain theorists, commonly referred to as the localizers, thought that the brain had different parts that localized specific functions. They pointed out that Phineas Gage's personality was never the same after the accident. The localizers believed that the damage to the brain caused the lasting change in Gage's personality. Ultimately, both competing schools of thought were integrated into contemporary brain theory. The brain does have specific localized functions. Modern research has shown that motor functions are certainly localized to specific areas. Localizers, however, underestimated the interconnectedness of the brain. The brain has trillions of synapse connections, and many human functions, such as memory, are impossible to localize to only one area in the brain. Recent studies have shed more light on Phineas Gage's specific condition. Damage to the frontal lobes has been shown to cause behavior spontaneity. Patients with frontal lobe damage often have difficulty interpreting information from their environments, taking risks, and complying with the rules. Especially with injuries that damage both lobes, a person's personality is often drastically altered. These recent studies help explain the effects of Phineas Gage's injury. Still, scientists wish to better understand Gage's disorder and the underlying brain science that could explain it.
Okay, so interesting case study, and so hopefully that helped you understand, why for the most part he functioned normally, but his personality was affected, his judgments, rational thought, because we now know that that is kind of controlled in that frontal part of the brain. Why did he survive? Well, turns out, his medulla, which controls our vital functions, was not damaged. And so his heart and his lungs still continue to work and beat fine. And so while he was not completely unaffected, he was still able to survive. Was he exactly the same? Clearly not. But, other areas of the brain, as we saw from those two competing schools of thought, while we do have localized areas of the brain that control specific function, the other areas of the brain can kind of learn to take over and can do some of the functions that that other areas of the brain were previously responsible for. So our brain can adapt somewhat to a certain extent. He lost a very large portion of his brain, and so he was affected drastically, yet he did survive. It's a very interesting case. All right, so this week you're doing formative number 11, functions of the brain on Schoology, worth 10 points. And if you're looking ahead to next week as the last week in the marking period, please plan accordingly. You will have 2 assignments next week. You'll have formative number 12, which is a study guide, and then you will have summative number 3, which is a unit test. It'll be on sections 2, which was on the psychological theories we've spent so many weeks on, and then section 3, which is this unit on the brain. All right, that's all I have for you. Good luck studying and good luck completing your assignments.